Constraint Satisfaction Problems, CSPs, in artificial intelligence involve finding solutions that satisfy a set of constraints. These constraints limit the possible values variables can take simultaneously. CSPs typically consist of variables, domains specifying the possible values for each variable, and constraints defining the allowable combinations of values. The goal is to find an assignment of values to variables that satisfies all constraints. Sure, let's use a smaller 4x4 Sudoku puzzle as an example. Problem 4x4 Sudoku. 1. Variables. Variables are the cells in the grid, each representing a position in the Sudoku puzzle. In a 4x4 Sudoku, there are 16 variables in total, one for each cell. 2. Domains. The domain for each variable is the set of possible values it can take. In a 4x4 Sudoku, the values can be 1, 2, 3, or 4. 3. Constraints. Each row must contain all the numbers from 1 to 4 without repetition. Each column must contain all the numbers from 1 to 4 without repetition. Each 2x2 subgrid must contain all the numbers from 1 to 4 without repetition. Problem representation. Let's represent the initial puzzle: vertical bar 1, vertical bar, vertical bar, vertical bar, 2, vertical bar. Vertical bar, vertical bar, 2, vertical bar, 1, vertical bar, vertical bar. Vertical bar, vertical bar, vertical bar, vertical bar, vertical bar. Vertical bar 3, vertical bar, vertical bar, vertical bar, 4, vertical bar. Solution. 1. Variables assignment. Start assigning values to variables one by one, adhering to constraints. 2. Constraint satisfaction. Ensure that no assigned value violates any constraints. If a constraint is violated, backtrack and try a different value for the variable. 3. Backtracking. If a constraint is violated, backtrack to the previous variable and try a different value. Continue this process until a solution is found. 4. Solution verification. Once all variables are assigned values and all constraints are satisfied, verify that the solution is valid. Check each row, column, and subgrid to ensure that it contains all numbers from 1 to 4 without repetition. 5. Optimizations. Apply optimization techniques like constraint propagation and heuristic methods to improve efficiency. 6. Completion. Once a solution is found, the Sudoku puzzle is complete, and all cells in the grid have valid values satisfying all constraints. This breakdown should help you understand how AI approaches solving Sudoku puzzles by systematically assigning values to variables while ensuring that constraints are satisfied.